Before we look at problem 17, let's look at some general understandings that are going to be helpful here. So we need an equation. A lot of times we want the reaction to proceed well to products, and when that happens, remember that's when the reaction is spontaneous. The delta G is negative. It proceeds well to products. And this can happen, certainly it'll happen if both the delta H are favorable and the delta S is favorable. Delta H is favorable when it's an exothermic reaction, when it gives off heat. That's when its sign is negative. Delta S is favorable when things become more dispersed. The energy becomes more dispersed, and that's when it's positive. So you see an increase in entropy. If those two are the cases, if delta H is negative and delta S is positive, the reaction will have to be spontaneous. The opposite is sort of easy to understand as well. If you had a situation where delta H was unfavorable because it was an endothermic reaction, it absorbed energy, and delta S was unfavorable because, say, gases turned into solids, things became more organized, that would be a negative delta S, then there's no way that the reaction could be spontaneous. Well, so what do you do if you're in a situation where you have differences between the delta H and the delta S? Like, say, for instance, the delta H was favorable, it had a positive delta H, and the delta S was unfavorable, it was negative. Well, in order to get delta G to be spontaneous, remember delta G has to be negative to be spontaneous, you're going to have to in some way minimize this unfavorable term. And the way to do that is to lower the temperature, and you'll reduce the importance of and the magnitude of that entropy factor right there. So you'll reduce the influence of the unfavorable part. Now, this is the argument that you're going to use up above in number 17. The question suggests that the reaction is non-spontaneous. So I want you to decide, based on our discussion down below, is delta G positive or is it negative? They say the entropy change is 87. Entropy, is that delta S or delta H? It's definitely delta S. And you'll notice that it's positive. I want you to decide if that's favorable or unfavorable. And then it says, what can you conclude about the magnitude of delta H? And so you're going to run through that argument. Does delta H have to be positive or have to be negative in order for the reaction to turn out so that the delta G is non-spontaneous? Now, to calculate the kilojoules of the delta H, you notice that we have some values. We'll know the delta S. We know the temperature. Probably going to want to convert that to Kelvin. And let's assume that this is just a little bit non-spontaneous. So you could put in 0, even though that's right at equilibrium, or you could put in a very, very, very small number, but then you can solve for delta H and you can figure out what the kilojoules are. Remember to be careful that we tend to measure this in kilojoules, we tend to measure that in joules, and this we tend to measure in kilojoules, so make sure that you have the units all the same.